Hi, everybody. I thought after today's class and after talking with a few students, I thought it would actually be good to kind of make a short video sort of going over some of the main points of the last few classes. And I can tell that there's some confusion, and my goal is for there to be as little confusion as possible. Now, that's not always 100% possible because it is science. Part of science is at times getting confused. I've gotten confused so many times in my science career, so don't be discouraged by it. But with that said, I want to help clarify things that might otherwise still be confusing. So what I thought I'd do is make a short video, about 10-15 minutes. You can pause, rewind, fast forward any way you want. If this makes total sense to you, then awesome. If not, just a resource I want to make available to you. So I wanted to talk a little bit about wind. And I wanted to talk about the main forces that act on the wind, that affect the wind, that speed the wind up, that slow the wind down, that change the wind's direction. What I really want to talk about is what's called the pressure gradient force. And the pressure gradient force is caused by differences in pressure. Now, with that said, how do we get high pressure? How do we get low pressure? How does this actually happen? Well, it all begins with temperature, and so I drew this little diagram. It looks very similar to some of the ones that I've shown in class, and it's right here. I can move up a little bit and talk a little bit about what's going on. So in this diagram, I have an area of warm land, and as a result, you're going to have warm air. Now, warm air rises, and because it's rising, because we now have more air aloft, higher above the surface of the earth, we have high pressure aloft. So warm air rises, creating high pressure aloft. On the other hand, on the other side of my paper, I have an area of cool land. Cool land creates cool air. Cool air sinks. As a result, there's less air molecules up here. That creates low pressure. Now, with that said, and I've said this a few times already, but Mother Nature doesn't really like imbalance. A natural system wants to seek balance. And in order to do that, air will move from the place where the pressure is higher over to the place where the pressure is lower. And this is called the pressure gradient force. The pressure gradient force is the force that moves wind from high pressure to low pressure. This happens in this first step, this happens aloft. So this happens well above the surface of the earth. This could be a few thousand feet. This could be tens of thousands of feet. It actually depends on the particular situation. Now, with that said, what actually happens is as air aloft moves from that high pressure in the warm air over to the low pressure that was caused by the cold air, this causes surface pressures to change. Over the cold air mass, because air is being added aloft, that causes surface pressure to rise. As air is being added over here, that's going to create high surface pressure. On the other hand, as air is being removed from the warm air mass, that causes surface air pressures to lower. Less air, therefore less pressure. So we get a situation where at the surface, you get high pressure over the cooler air mass, low pressure over the warmer air mass, and then winds again blow from high to low. The pressure gradient force works again. So what you end up getting is this circulation, this atmospheric circulation, where warm air rises, creating high pressure aloft. Cold air sinks, creating low pressure aloft. Winds then move from the high pressure aloft to the low pressure aloft. Eventually what happens is the pressures up here even out. They equal each other. That's called equilibrium. However, at the surface, because air escaped the warm air mass, that causes low pressure to develop at the surface of the warm air mass. High pressure develops at the surface of the cold air mass because air came into the cold air mass. And so we get high pressure that develops here. And then again, winds move from high to low. Now, one of the things I really want to stress here, a lot of people get confused when they think hot air, cold air. Think about high pressure and low pressure. That's what I really want you to get. I want you to understand the ideas of high pressure and low pressure. Now, with that said, we call this the pressure gradient force. And the pressure gradient force takes wind and it moves it from high pressure to low pressure. And the pressure gradient force, the intensity, the strength of the pressure gradient force is determined by two things. It's determined by the difference between the high pressure and the low pressure. So if this is a really intense high pressure system, let's say 1,040 millibars, and this is a really intense low pressure system, let's say 950 millibars, so there's a 90 millibar difference between the two. That is a high pressure difference. That is going to result in a fast moving wind. This is actually why winds and hurricanes oftentimes are really intense, because the low pressure tends to be really low. And so that triggers a really fast wind. The other thing that affects the pressure gradient force is the distance. If I were to take this high and this low and move them further away from each other, that would actually cause the winds to weaken. So that's the pressure gradient force. Winds move from high pressure to low pressure in order to achieve equilibrium. The speed at which they move is determined by the difference and the distance. The difference between the high and low pressure and the distance between the high and low pressure. Now, with that said, as the wind begins to speed up, as the pressure gradient force accelerates the wind, because forces accelerate wind, what we end up getting is we end up seeing an additional effect caused by the rotation of the Earth. This effect is called the Coriolis Effect, and it creates a force called the Coriolis Force. And the way the Coriolis Force works actually depends on the hemisphere that you're in. If you are in the northern hemisphere, winds will shift to the right of their path. Now let me stress, when I say to the right of their path, I'm talking to their right, not to your right, to their right. For example, this air molecule is moving north and it shifts to its right. On the other hand, in the southern hemisphere, that same molecule moving in the same direction shifts to its left. So it shifts to its right in the northern hemisphere, to the left in its southern hemisphere. And there are three things that determine the strength of the Coriolis force. The first one is latitude. If you live right near the equator, no Coriolis force. However, the further away you get from the equator, the greater the Coriolis force becomes. On the other hand, if you get up towards the North Pole, the Coriolis force becomes larger and larger and larger. As you move back down towards the equator, it becomes weaker and weaker and weaker. The second thing that affects the Coriolis force is the speed of the wind. If the wind is traveling really fast, it's going to have a higher Coriolis effect. This is why if you look at hurricanes will spin very rapidly because that Coriolis effect is really intense. The last thing, and then so when winds slow down, the Coriolis effect weakens as well. And then finally, the size of the motion. This is why as you're walking down the street, you don't feel the Coriolis force tugging you to the right, because you are a very small object moving a very short distance. That's a small motion, not really big enough to have a Coriolis effect. It's practically negligible in that case. So that's just a breakdown of the pressure gradient force and the Coriolis force. The third force, which I didn't bother to draw up something, is friction. Friction slows the wind down at the surface. And friction is only important in the lowest 1,000 meters, which we call the planetary boundary layer. All right, so I'm hoping that this at least clears a few things up. Please email me your questions. Please come to my office hours. Even if you can't make it to my scheduled office hours, I'm happy to make appointments. I know you can get this, and that's what I want to see. I want to see this make sense. I want to see light bulbs go off because I know you can do this. So that's that. If you have any questions, please let me know. Otherwise, happy Halloween, everybody. And also, I actually do record some of my lectures, and I actually do have recordings of these lecture videos. I'm going to put them in the comments below. All right? Actually, in the description below. All right? Happy Halloween, everybody.